This is the study session on corporate finance, and this is the reading on capital budgeting. Before I get into the slide deck, I want to give you a good, simple definition for capital budgeting. It's the process of planning for the purchase of long-term assets. Now, what I don't want you to do is I don't want you to think of long-term assets as the property, plant, and equipment that accountants record on a firm's financial statements, even though that's what they are. I don't want you to think of them in terms of the machinery or the pieces of equipment or the buildings that I envisioned property, plant, and equipment when I was first exposed to the capital budgeting process as an undergraduate student many, many years ago. No, what I want you to do is I want you to think of capital budgeting as the process of producing product lines. For example, I want you to think of a motorcycle making company, and I don't want you to think of the metal stamping machines. I would prefer that you think of the feeling that a motorcycle owner gets when they're driving down the highway 40 or 50 or 60 miles an hour with their hair blowing in the breeze, with not a care in the world, thinking this is freedom, that feeling of freedom of riding a bike down the highway. That is the ultimate way to think of the capital budgeting process. What it does is that it puts a personality on the capital budgeting process, and that's what I'm hoping to do today. So let's look at the first LOS, describe capital budgeting process and distinguish among some different types and different categories of projects. So there's a good definition. Refers to the process of planning expenditures on assets whose cash flows are expected to extend for a period of greater than 1 year. And frequently these are multiple years, 5 years, maybe even 10 years. These projects can be classified as replacement products, which is exactly what the name suggests, replacing old or worn out equipment with new and more efficient equipment. Let me give you a personal story. When I was in college, I worked in a donut factory, and the ovens and the heating machines and the baking machines, when I first got there, in the first summer that I worked, were kind of old. They used to break down. There was a mechanic on duty, and he had to come in and get his screwdriver and all sorts of stuff and fix them. And of course, that's no good because it breaks down the process and it delays production and it reduces cash flows. So what the owner of the donut factory did is one day we came to work and there were all these brand new machines. And the machines worked perfectly and we were able to increase productivity. That's a replacement project. Another example in the donut factory is the following summer I showed up for work and they had knocked out the back of the factory and put some new machinery in the back of the factory. And so they expanded their product lines. And what happened was that we started making donuts and putting them in boxes and putting them on a truck and sending them up and down the East Coast. And so the donut owner was able to expand geographically by expanding his physical plant. Here's one of my favorites, brand new products or services. And I'll go ahead and use the icebreaker example here. I'm guessing that everybody has heard the name of Milton Hershey. Milton Hershey's been making chocolate for a really, really long time. Everybody knows the Hershey brand name, Hershey Kisses and Hershey Chocolate Bar. Well, one day about 20 years ago, Milton Hershey woke up and said, you know what? I think I would like to improve the breadth of all of the people out there who eat candy. Now, of course, Milton Hershey has passed away for some time, so it was the executive leadership of the Hershey Company who decided to expand their product line into icebreakers. And originally, people thought, you know what does Milton Hershey know about fresh breath? What do they know about sugar and peppermint and all that stuff? But interestingly enough, what's happened over the last 20 years is that Icebreakers has become its own brand name. So this is a great example of a successful launch of a new product line. How about some regulatory or safety or environmental projects? And these are projects to comply with requirements set by an external party, such as a government. They may or may not generate revenue. There's a company called Cheetah Marine that manufactures boats. And they have a fascinating model where they emphasize things like safety, they emphasize things like stability, but they're very environmental and safety aware. All of their boats have special safety devices and processes, but they've also developed one of the first, if not the first, hydrogen-powered engine. And so they're very concerned about pollution and reducing pollution and having their boats be safe and fun and yet environmentally aware. And then there are some other projects that might be a pet project or a highly risky project. Here's some steps in the capital budgeting process. Step one is to generate and brainstorm ideas. And what I want to do is I want to go back to an example that I used many times throughout these videos is Apple. I bet you guys are aware that Apple recently became a $1 trillion market value company. How has it done that? Well, it's developed product lines that people all over the world not only want, but they demand, and they're willing to pay a relatively high price for it. But I want to tell you another personal story. When I was in college, I did a lot of traveling on buses. And I was bored on buses, and I remember telling my mother this. And for Christmas that year, she bought me this little box. And in this little box, I could put a tape. And I had some headphones that I could stick into my ears. It was called a Sony Walkman. And it revolutionized the way we listened to music in the early 1980s. And that relates to Apple, because these really smart men and women at Apple, they were sitting around in the 1980s thinking, you know what, how can we make this process more efficient? Because I could only listen to, let's say, 30 minutes of music at a time, and then I had to flip the tape and put it on the other side for just another 30 minutes. But look at what you can do with the iPhone now. You can listen to, boy, dare I say, millions of hours of music. You can listen to a book. You can call somebody on this phone. You can control your garage door opener. You can monitor blood sugar. I mean, there's all sorts of crazy stuff that you can do with the iPhone. And that all started with brainstorming does the future hold for the demand for products like that. The next step then is to try to conceptualize and put this in a mathematical framework. It's one thing to be able to develop a product line that's in demand. It's the next step to be able to put it down into mathematical cash flows. That's why lots of executives have master's degrees in statistics or economics or finance so that they can estimate and predict accurately those future cash flows. The third step is to plan the capital budgeting based on the timing of those cash flows, both in and outflows. And then lastly, we're going to continuously monitor the project. And then make certain the financial results are audited so that we can evaluate the performance. Clearly, when Apple goes through this step 4 and they look at the iPhone in their hands, they say, hey, by any metric, this has been a success. All right, why is capital budgeting important? It's extremely important because it's part of the company's strategic plan. Those long-term assets, that property, plant, and equipment, has long-term operational implication for the success of the company. Now, the other part of this is that a commitment to a capital budgeting project is a several-year commitment. So we're committing several years worth of cash flows and company resources and all sorts of other stuff to make certain that that project is successful. All right, describe the basic principles. The decisions are based on cash flows. One of the most principal elements in any first-year corporate finance textbook is that cash is king. You read this all the time. Accounting concepts are based on things like net income, which follow accounting rules, like sum of the year's digits depreciation or a one way to value inventory. The important thing is that net income can be changed based on the rules and the regulations that are selected by the company. Cash flows are less easily manipulated, so they mean something real in terms of profitability and return to shareholders. Timing of cash flows is critical. It's one thing to spend $100 today and then get $120 a year from now, but it's an entirely different project if you spend $100 today and get $120 30 years from today. So timing is critical. Cash flows are based on opportunity cost. I always like to use this example. When I go to the beach in the summer, I'm fascinated by the idea that there are so many miniature golf courses down at the beach. And I always think to myself, wow, I wonder what the opportunity cost of running that miniature golf course is. I mean, you could put a restaurant, you could put an apartment building, you put a high rise, et cetera, et cetera. But those opportunity costs are critical in determining cash flows. Have to be after tax. Of course, it has to be after tax because taxes will reduce the cash flow to the shareholders. Financing costs, on the other hand, are going to be ignored. This is going to be discussed in the weighted average cost of capital video, in which we consider the bond issue or the bank loan in the required rate of return. We're going to ignore those when we compute cash flows. Here's an important bullet point there at the bottom. Those capital budgeting cash flows are not the same as accounting income for those reasons that I mentioned earlier. Distinguish among various categories and key capital budgeting concepts. Let's get some definitions here. Sunk costs are those that are already incurred. We're going to ignore those things. Opportunity costs, we mentioned that, best foregone alternative. Externalities, this is important. These are the effects that the project has on other variables out there. What's extremely important, going back to my Cheetah Marine example, is the impact on environment. So a company like CM is reducing its carbon footprint by using the water. I mean, after all, right, boats, they're in the water. So isn't it a cool thing to use the water, use the surroundings to power the boat, and it's friendly on the environment. Now, a lot of capital budgeting projects have conventional cash flow patterns in which a huge cash outflow occurs today, followed by lots and lots of positive cash inflows in the next several years. But it doesn't have to be that way. There can be unconventional cash flows in which there's a huge investment today, followed by a period of positive cash flows, but then maybe there's another negative cash flow in the future. And of course, we're going to always deal with incremental cash flows. Next, LOS. What about mutually exclusive projects? What about project sequencing and capital rationing? So we're asked to explain independent versus mutually exclusive projects. Independent projects have independent cash flows. In other words, we're going to evaluate an independent project based solely on its ability to generate cash flows. We're not comparing it to any other investment. And that's what mutually exclusive projects are. This is where you have to pick one or pick a few among a variety of projects. And the example that I always like to give is an irrigation system for a golf course. Suppose that you're the owner of a golf course and your golf course is brown because it sits on the side of a hill and somehow it doesn't get any rain. So you need an irrigation system. And so you pick up the phone and call a plumber and ask the plumber to come out to your golf course and say, hey, look, I need pipes throughout my golf course. I need to water my entire golf course. So the plumber does all sorts of stuff and he says, hey, I can do it for $250,000. Well, those of you who are homeowners know that when you call a repairman into your home and you ask him or her for a bid, you know that you're going to ask the next person to come in and make another bid. So you always get a second opinion. So of course, as the owner of the golf course, you're going to call up a different plumber and have him or her come out and do the same kind of stuff. And suppose that second plumber says, you know what, I can do all this and it's going to cost you $270,000. Does that automatically mean that you reject the higher bid and accept the lower bid? Well, it depends on how that irrigation system is going to increase the cash flow for your golf course. But mutually exclusive means that you're not hiring both plumbers. When you accept one plumber, you reject the other plumber. That's the nature of mutual exclusivity. Project sequencing. This is so cool. This goes back to my Apple example. What did Apple begin with? However many years ago, Apple, of course, they've been doing PCs, but then all of a sudden they came up with this laptop computer. And then they came up with this iPod. I remember I bought my first iPod in, boy, I don't even remember what year it was, 2000. And I was able to put 1,000 songs on this iPod. And I was thinking about my days in college, and I thought, man, if I'd have had this thing in college, I would have been so much cooler. But certainly, you know, those people at Apple, they were thinking, okay, I can do songs on this. How about if I can combine a phone and the songs? So project sequencing means that one investment paves the way for another one. How about capital rationing? Of course, we never have unlimited funds. We're going to have to ration, so we're going to have to order several projects by their degrees of profitability. And I'll explain how we do that here in just a little bit. So capital rationing exists, of course. Everyone has a budget. We know that when we have children, we can't go out and buy them lots of bicycles and iPads and television sets and PlayStations and all that kind of stuff. We have to ration. All right, so here's the question. We're faced with capital budgeting. We know we have all these product lines that we're thinking we want to invest in. How do we make the decision? And the answer is we use some capital budgeting tools. And these things are NPV, IRR, payback, discounted payback, and profitability index. So that's what we're going to do over the next couple of slides. Now, let me just remind you, going back to the very beginning of corporate finance, what's the goal of the business? Maximize shareholder wealth over the long term. How do we do that? Well, we find projects that have positive net present values. Let me show you what that means. So the first way that we're going to evaluate a capital budgeting project is through something called this net present value method. And it's actually relatively straightforward based on time value of money stuff that we did back in one of those early readings. It really is just the present value of the cash inflows minus the present value of the initial investments, which most times are in present value terms anyway. So we're going to invest in a project if and only if its NPV is positive. So here's that quick math example that I gave you earlier. Suppose we invest 100 today and we receive 120 in 1 year. So we invest 100 today, we get 120 in cash flows in a year. Let's suppose we have a 10% required return. What is the net present value of this project? And so here's what we do. We take out that 100, which is a present value. That's the initial investment. And we add to that the present value of that future cash flow. So we take the 120 divided by 1 plus the 10%, and we get 9.09. So that net present value is positive, and we say, therefore, we want to accept this project because it's going to increase our wealth. And that's really important. Net present value explicitly measures the change in shareholder wealth. So if the goal of the business is to maximize shareholder wealth, it ought to make perfect sense that we do that by finding projects that have positive net present values. Now, there's the formula in blue that you can use, but you're not going to use that, especially on an exam. Just go to the financial buttons on your calculator. And this is an easy one. All we're going to do is use our 5 time value of money buttons. We're going to input future value is 120, interest rate is 10, N is 1, payment is 0. And we're going to compute present value. That gives us the 109.09. And then subtract out the 100. So there's the 9.09. I'm going to show you a shortcut here in a few slides. The next way is to compute the internal rate of return. Now, the internal rate of return is going to seem like it's very similar to net present value. And in fact, it is. We're going to consider the same initial cost. We're going to consider the same prediction of those future cash flows. But what we're going to do is, instead of solving for dollars of net present value, we're going to force the net present value to be 0, and then we're going to solve for the interest rate. That's the internal rate of return. It's the interest rate or the discount rate that produces a net present value of 0. Now, the decision rule is that we're going to invest in any project in which the IRR exceeds the required rate of return. Now, we're going to talk about the required rate of return in a future video, but let me go ahead and just give you a sense here. Let's go back. And we know that this project has an initial cost of 100, right? Could be $100, could be $100 million. The question is, where do the owners, where do the executives get that $100? And the answer is, well, they borrow it from the bondholders and they borrow it from the shareholders. And in this case, the bondholders and the shareholders are saying, hey, you can have our money, but you better earn 10%. So if the IRR of the project is greater than the required return, then it's an acceptable project. So let's go ahead and solve for the IRR with that same example that we just did. So there's a good formula. So notice the equal sign there on the right. We force the net present value to be 0, and we solve for the interest rate. Now, to do that mathematically, you have to kind of guess at the IRR and then guess again until you get a net present value of 0. There's the general formula there, but don't use that formula. You're going to use the 5 buttons on your calculator. So make present value 100, make future value 120. And remember, when you're solving for the interest rate, you need to make one of those two negative. It doesn't matter which. I'm always in the habit of making present value negative, and his one payment is 0, and you get 20%. Now let's go ahead and calculate the net present value and internal rate of return for a project that has multiple years, right? This project back here just had 1 year. So let's go to my golf course owner, hires a plumber to install an irrigation system, initial cost $250,000, and the owner estimates the cash flows are going to be. So we're out $250 today. So we hire the plumber, we pay him $250, and what does he do? He comes and digs up our golf course. He puts in a water pump, and he puts in pipes, and he puts in sprinklers and all sorts of stuff all over the golf course. And what does that mean for us over the next 5 years? What that means then is that our golf course is going to become green. We're going to be able to plant flowers. We're going to be able to plant bushes. Maybe we could put in a pond. And so we think that in year 1, we're going to get $58,000 more of cash flow because the demand for our golf course will improve. And then 59 and 64, notice those cash flows are increasing over time. And that makes sense because our golf course is going to be greener. Our trees are going to grow more beautiful. Maybe we have a pond in there somewhere. And then one year we put in ducks, and the next year we put in geese, and the next year we put in wildebeest, and then we put in crocodiles, and we have Wild Kingdom on our golf course. Of course, I'm being silly there, but nevertheless, what you're getting, you should get the point that over time, our golf course quality is going to improve. So it's reasonable to expect higher cash flows in the future. Now, let's suppose that the required return is 8.1%. We can go ahead and use our cash flow button on our calculator to compute NPV and IRR. And this is how easy it is. I'll let you guys pause the video to make certain that you can come up with an NPV of 2703 and an IRR of 8.49. So this is what you're going to do. You're going to go into the cash flow function, make cash flow 0 a minus 250. Don't forget the minus sign in front of that. And then cash flow 1 is 58 and 2 is 59, et cetera, et cetera. Don't forget to put the I as 8.1% in at the end, and then just hit the compute NPV and compute IRR. So go ahead and pause and make sure you can compute those two numbers. Oh, and by the way, we're going to say therefore accept regardless of whether we use NPV or IRR, because NPV is greater than 0 and the IRR is greater than 8.1. How about the payback period? Payback period is defined as the time until the cash flows in the future recover the initial investment of the project. Now, there are lots and lots of really good things to like about NPV. There are almost as many good things to like about the internal rate of return, but there are lots of reasons not to like the payback period. First of all, because it ignores the time value of money, and second of all, it ignores cash flows beyond the payback period. Nevertheless, the payback period is part of the LOS, so let's figure out how to compute this thing. Here's an example. Suppose we spend $5,000 today, and we're going to have cash flows of $1,500 and then $3,500 and $4,000 and $4,000. So this is a 4-year project. So how do we compute the payback? Putting this together in a timeline maybe visualizes this a little bit. So notice that we're out $500. we're out 5,000 initially. So in the first year, we get back 1,500. So we're still 3,500 away of recovering our initial $5,000, right? So in year 2, we get back that 3,500, and so our cumulative cash flow is 0. So there's our payback period of time period 2. Problems with payback, once again, ignores time value of money. And there's really no great decision rule about payback. Like, do you want to accept a project that has a payback of less than 2 years or 5 years or 8 years? I mean, how do you really come up with that number? But suppose you came up with a decision rule that said you want to invest in any project that has a payback of less than 2 years. And let's go out to year 3 and change that 4,000 to 400,000 in year 3. So because the payback is, let's say, 1.9 years, you would reject it because this payback is 2 years, and yet you would be rejecting the 400,000 or whatever that huge number is I said in time period 3. So payback has some problems, but it's simple and it gives you a sense of how long it's going to take to recover that initial investment. Now, one way to manage that first problem, what was that first problem? It ignores time value of money. One way to manage that problem is to compute the discounted payback period. All right, so let's go ahead and do the same thing here with that particular project, but let's suppose that we're using a discount rate of 10%. All right, so we do the same thing. We put together the same table, but we're going to need a couple more rows. And the way we're going to work this then is that we're going to take our cash flow in year 1 of 1,500 and take the present value of that. That gives me the 1,363. I'm going to subtract that 1,363 from the 5,000. You see how we're doing this? The cumulative discounted cash flows rather than the cumulative cash flows that we did in the simple payback. And so notice there that under the cumulative cash flows, we're at 0 after 2 years, but we're still at a minus 743 at the end of year 2. And then we get 4,000 in year 3. So we know the discounted payback occurs somewhere between year 2 and year 3. It's going to be a fraction. It's going to be a fraction of that year. And so all we do is take a ratio. We take the 743 and we divide it by the discounted cash flow amount of that. What is that? About $3,000. So we get 2.25 years. Profitability index is a different way of looking at net present value. What it is, it's a standardized net present value. And so look at a couple of formulas there. Profitability index is going to be the present value of those future cash inflows divided by the initial investment, or alternatively, you can do 1 plus the net present value over the initial investment. And so, I mean, here's the thing. Whenever NPV is positive, the profitability index will be greater than 1, and whenever the NPV is negative, it will be less than 1. And so the decision rule, if our decision rule was to accept any project that had a positive net present value, we're going to have a decision rule to accept any project that has a profitability index greater than 1. So here's a quick example. We have an initial outlay of 100 and we have a negative net present value of 24. So we're going to reject this project. What is the project's profitability index? And so since we're given NPV, let's use that second version of the formula. We take the 1 plus the 24, which is less than, right? It's less than 0, so we're subtracting from 1, so that gives us 0.75, less than 1, so we reject this project. All right, how about the profile? This is a great picture in which we're going to graph the relationship between dollars of net present value on the vertical axis and potential interest rates starting from 0 at the origin all the way out to some big number. All right. Now, the interesting thing about this NPV IRR profile is that the relationship is nonlinear. And you guys should know that from our discussions back in quantitative methods. Whenever you have one unit on the vertical axis, like dollars, and another unit that's different on the horizontal axis, like interest rates, the relationship may not be linear. In this case, it's not going to be. And so we have a downward slope. This is important. The NPV IRR profile is always downward sloping because as the discount rate increases, the net present value falls. So therefore, it is downward sloping. Now, a couple of different things here. Notice that the intersecting point on the horizontal axis is the IRR. That's the special discount rate that forces the net present value to be zero. And this graph illustrates the importance of how government activities and economic activities influence the capital budgeting decision. Notice that the net present value is positive to the left of the internal rate of return of the project. What does that mean? That means that it's important for corporations to operate in a low interest rate environment. When interest rates are relatively low, then companies can find positive net present value projects. On the other hand, when interest rates are high, it's tough to find positive net present value projects. That's why when interest rates are low, the economy tends to expand because firms are finding positive net present value projects. And when interest rates are high, the economy tends to not expand or contract. And so this has implications to employment and exchange rates and trade and all that kind of stuff. So our simple capital budgeting model here in this reading has implications that reach throughout the CFA program. All right, let's compare NPV and IRR for independent and mutually exclusive projects. When a company is faced with independent projects, both NPV and IRR will always result in the same decision. In other words, if the NPV says invest in this project, the IRR method will agree. And that's true because the NPV can only be positive if the IRR is greater than the required return. But when there is a conflict, sometimes when you're evaluating mutually exclusive projects, let's go back to our plumber example. Suppose that both projects have a positive NPV, but plumber 1 has an NPV of 100 and plumber 2 has an NPV of 80. And then plumber 1 has an IRR of 9 and plumber 2 has an IRR of 11. What do you do when the IRR method and the NPV method disagree with each other? And by the way, this can only happen when projects are mutually exclusive. And let's go back to what I said at the beginning. What's the goal of the business? Maximize shareholder wealth. What does the NPV method measure? It measures explicitly the change in shareholder wealth. So you should always use the net present value method. Now, there's a follow-up reason to this, that the net present value method assumes that the cash flows are reinvested at the required return, at that cost of capital. The IRR method assumes that the cash flows are reinvested at the internal rate of return, and the NPV method is much more realistic. Now, sometimes you could get multiple IRRs and sometimes you could get no IRR. So what do you do? What do you do if the IRR for a project is 4% and it's 96%? Well, then you just scratch your head and you say, okay, I'm not really sure what to do. Well, what do? You go back to net present value. Now, what's the goal of the business? Maximize shareholder wealth. What are we trying to do as bondholders and shareholders? We're trying to encourage the executives to invest in projects that are going to increase our bond price and increase our stock price. So whenever a firm invests in a positive net present value project, stock price should rise. Now, when you watch one of these business shows on television, and an executive is being interviewed, they will never come on and say, hey, we have found a positive net present value project. They always use the terminology wealth increasing. And so they'll come on and say, hey, this is a wealth increasing. Like you can almost hear Milton Hershey say, yes, Icebreakers is a wealth increasing project. And so when you hear that and you read about it in the Wall Street Journal or some other financial newspaper, wealth increasing, that means that the executives have found positive net present value projects. And what that ought to mean is that stock prices ought to rise. And those stock prices are based on the expectations of investors about the success of that particular product line. And that takes us through capital budgeting. Next up is the reading on cost of capital.